Welcome to Plan 5. In Plan 5 we'll be doing all the parts components for the front end. We'll also be making these 3 forming bucks. One is for the bonnet. The second one here is for the radiator shroud. We'll be using that as a hammer form. And the third one is to make the louvers in the side of the bonnet. During the making of our parts and components, we'll be using all the skills that we've already covered. We'll be developing them even further. Metal shaping, shrinking, stretching, metal finishing, swaging, louvers, even machining work. Even something like this firewall that is identical to the back of our forming buck. Making the panels that then fit together and we can bolt it all together on the car. So let's get to the plans. On Plan 5, drawing 17 are the front end assembly and components for the bonnet. We've got all the part location and numbers. In sequence, we'll be making the right and left hand inner wheel arches, the headlight support bar, the radiator shroud. We'll also need a hammer form for that as well. On the bonnet, we'll also need a forming buck. The side panels for the bonnet, we'll be doing a hammer form for the louvers. With the front valance, we'll be making that as well, and we'll be finishing up with the radiator temperature gauge. Let's get started with the wheel arches, part number 106 and 107. We're up to drawing 20, our wheel arch templates. We'll need some 1mm mild steel, 300 by 900. We'll also need to cut out our templates, T28 and T29. We'll need to cut out our wheel arch profile because later we'll be using this to overlay on the forming buck, and it gives us this radius, also location points with the guard. We need to bend our wire to WT1 and WT2. WT2 is the form along the front. WT1 is direct vertical. This is the most complex piece that you've made yet. It's a 3-dimensional form. I've cut the 2 templates out. We've got some laser cut blanks here with our holes already done. We've also got our fold lines. If you're doing it by hand, don't forget to mark your fold points and your drill holes. Also, we need to mark 1 and 4 are 10 and 15mm flanges. They will be folded down, so we'll have to mark the back side. For fold 1 and fold 4, we'll need to set our dividers. Fold 1 is 10mm. We'll be marking the back side of the fold because it's going to go down. Fold 4 is 15mm. We'll also be marking the back side to go down as well. To take our flat piece of sheet metal into a 3-dimensional form, we'll need these 2 template profiles that are on drawing 20. WT1 is the profile directly above our fold point here. That's the highest point in the guard. WT2 is this curved front face or safety fold. You can see here the 3-dimensional form that we've got is the most complex piece that you'll have to make yet. This top fold here will also line up with our forming buck to then later on be welded or attached to our front guard. To make the wire form, I'm using some 1.6 high tensile TIG rod. You can also use mild steel, even aluminium TIG wire. To do that, we'll simply follow our red outline as to the curvature and radius that we'll need. With this, what I do is slide it across the middle of my thumb to give you a constant radius, a nice, smooth, even, constant radius. So just working one section at a time, start from the fold point and work your way all the way out to the outside edge. To form this piece with hand tools, the first thing that we'll be doing is turning edge number 1 with our combination pliers. We need to turn it upside down and begin the process by turning the lip up. First point is we come in with the pliers, then we skip a space. The third jaw point We come up to about 75 degrees with each of our folds. Then we skip another space. Again, up to 75 degrees. We follow that all the way along. Then we'll come back, and the areas that we missed out, we'll bring that to 90 degrees. There is a trick to this process. You can see here it's quite square. You need to squeeze hard, push in and down as hard as you can. So now I'll come back in the sections that I missed previously. You can already see in the front section here we're beginning to get our curvature. However, this edge is quite rounded, it's not in shape, it's not square, and we need to continue shrinking through this section to create our curvature. We've got edge 1 at 90 degrees, however, we're nowhere near close enough as far as our radius, so we need to shrink this face. If you don't have a shrinker and stretcher machine, then we can use hand tools. Simple shifter, a larger shifter to give you a little bit of leverage, and what we do is insert the jaw, then make sure that when you twist it, the peak of the metal is facing this way, because later on we'll be going over here using some of this round bar to then planish and smooth out. You can see quite clearly it's forming a pucker, and you can actually see the sheet metal beginning to shrink. You can see here these ruffles or shrink puckers, etc., are facing the outwards direction. So therefore, later when I come along and planish it, it'll be working inwards. If you go inwards, then it's going to be counterproductive. It's not going to work the way you expect it to work. You can also see from the front profile how much that's beginning to curve. The tooling that I'm using, you could simply get some solid round bar and make this into a T-dolly, which I've done. Machining the front off. I've got a forming stake here. Now that's an industry tool specific. However, solid round bar, about 70-80 mil OD will suffice. It'll do exactly the same job. Using the machined shoulder of our forming tool, place the corner or the edge of the sheet metal right in position over the edge of the turned round bar. We can then apply a little bit of downwards force. So there's two things that will happen. Number one, we're going to be planishing this front face, the vertical face. Number two, we also need to apply a little bit of load, just with your chest, etc. Or somehow or another, you need to leverage to get yourself in the right position. So a left-hander will come in from this side, a right-hander from the right side. The secret with this method is working along this top face and that face. Don't hit the corner. Don't hit the radius at all. So we need to come back here, repeat the process, continue the shrinking until we've got the correct radius, and we literally will start to form until that profile meets each other. With this method, you need to over shrink because it's quite easy to stretch it back out. You can really see how much radius that's pulling through there. In this direction here, right now, we're getting very close. As soon as I start to smooth it out, it will undo some of the work. So it's a multiple step process. I'll shortly be the process of stretching this outside flange so that we can start to meet or match these faces up together. Remember, we've come from a dead flat piece of metal. Now we're really beginning the forming process, but it's a step forward, half a step backwards. Continue step forward to go backwards. You can see how much that takes it out. This is where the advantage of shrinking jaws really speeds up the process. You can see here I've really over shrunk it. So on my second pass it met that radius. Third pass it's over shrunk. So we continue the process of shrinking, planishing it, re-shrinking, planish, but this will gradually get closer and closer every time we do it. You can see now why I chose that radius, because it's fitting in there quite well. Later on this will be a safety fold and I'll run the file over it and this will all be smoothed out. We'll dress it up. I've predominantly formed most of this front edge as far as shaped and shrunk, etc. The next one I'll be doing is our outer top edge where the guard will get attached. This I'll be turning outwards with our pliers and then stretching or hammering over our former to stretch that flange by simply stretching through the flange of the metal. I'm ready to begin folding the outside or top flange, simply using our combination pliers again. The nose of the pliers are on our scribe or line we've set with the dividers, folding this up gradually over a few passes until we get to approximately 90 degrees. Then we'll be stretching, linearly stretching with our hammer and using our dolly. You can see here we're beginning to lose a little bit of form or shape because we're stretching this edge up. So we'll need to just stretch, fine tune. So it's going to be a little bit of balance of both in the process. It's not complete one then the other in isolation. They both have to be fine-tuned in conjunction with each other. Ultimately, we need this to meet our forming buck. You can see here how much stretching has to be done to get this flange to sit right up into that corner. Believe it or not, that curvature ultimately will actually become a straight flange that will sit flush on our forming buck. I've now turned the outside flange to a vertical. I then need to linearly stretch the outside. However, with our wheel arch template, our side view, we'll need to cut that out, overlay it on our forming buck to give us the correct radius from start to finish. I've cut out the inner wheel arch template. We now need to cut along the dotted line and remove that section. Also cut along the dotted line and remove the front section. We can then overlay that from the rear on the forming buck. We'll mark both of those sections. That gives us the complete form or radius all the way from the start to the finish. It's significant because we need accuracy to get the guard to fit the inner guard later. I've cut the inner wheel arch template out, overlaid it on the forming buck, located it at the back, moved my way forward, attached with some masking tape. You can see this section here, we've got a radius difference. That's because later on, when the inner wheel arch is attached to the guard, this face here is secured, attached to the cross member at the bottom of the firewall. we can, with a white Chinograph pencil, highlight that, and also the front. We can then take this template, transfer all this information to the other side, and it will give us the correct form and curvature to fit. We've got our reference points marked on our forming buck. I can begin the process of lineal stretching through the top flange. We keep referencing at the same point. You can see here there's quite a lot of stretching to do. So start at the front, stretching through here until the back meets down here. We're heading in the right direction, so from this plane here you can see that it's all started to tighten up. However, a lot more stretching is required through this radius here. Front is good, the back is not far off, predominantly stretching through this area. Using the top face or the vertical face of our forming dolly doesn't really matter at all. Even a block of steel, anything that will do the job is fine. Just keep coming back and checking it against your forming buck. We're going to be doing a little bit more fine tuning just to make sure it sits nice and flat and continues to fit to that radius. We're nearly there, we just need to keep stretching until we get the correct form, curvature to meet our wheel arch template we previously marked. We've got our radius very close to correct. However, when you sit it on the bench top, you can see that we've got a gap through here. So we can correct that by a couple of methods. Number one, a 20mm steel plate attached or clamped to the bench top. We then clamp our steel inner guard to the steel plate. Using caulking tools, we can then flatten that. Don't use the bench top because you'll get spring back and it won't correct the problem. We have a welding table, so we'll be using the welding table. I've clamped the piece in place now. Here's a selection of caulking tools. Steel caulking tools will leave a mark on the inside face. However, the aluminium caulking tools will reduce any marking. Caulking on the inside flange, I come in at a 45-degree angle and work it down. As I come to a more vertical section, I will work it more vertical. I want this face to sit dead flat against the tabletop. We've now caulked that line and we've got that flange nice and flat, but it would have thrown out a radius. So we need to release it, trial fit it back on the forming buck just to check. I've now got the vertical flange fitting the face of the forming buck. However, it's undone some of our previous work. What it's done is shrink this flange. So we'll need to stretch again until this fits. It's a process of repeating caulking, stretching until we get everything to fit with the radius, because we'll bring the guard in and they have to fit together. Okay, we're pretty good now, so we're ready to trial fit with the guard. I've got the inner wheel arch now fitting the forming buck. It's flat and our curvature is correct. We need to introduce the guard. When we join these two together, we don't have a reference point. So we previously drew on the front of the forming buck a reference point. What we can now do is transfer that to the guard. Then we'll take it off. With some vice grips, we'll join these two together temporarily. And we can do fold 3 and fold 4. I've vice gripped the inner wheel arch and the outer guard together to give the inner wheel arch some form or rigidity. We can then do fold 3 in our vice brake press jaws to our wire template 1 to get the correct angle. For fold 3, It's 195 millimeters long, and we'll be doing it to WT1. With this one, we're using the vice press brake jaws. However, the vice press brake jaws are only 125 millimeters long, so we'll be doing it in segments. So take your time, don't overdo it. Make sure that you don't hit the corners of the female die, leaving high spots or dimples in the guard. When I apply force or pressure on these, what I often do is just support the guard, etc. This is part of the reason why we join these together, giving it a little bit of a stiffness and also support. If you're allowing it just to do it on its own, as I said, you may get some dimples or high spots and a little bit of damage, so please be careful. We've completed fold 3, now we need to move on to fold 4. We're up to step 5 and step 6, where we need to initiate or just manipulate the metal slightly to begin a bend. That's across the back here, measure up 12 millimeters and a very slight fold, just a few degrees, because this face has to be vertical when we mount it to the cross member. Also, step 6 is 43 degrees from our fold line. Measure up, draw it out, and just manipulate the metal, enough so that you're introducing a very subtle fold line. We need to measure up from our bottom flange here, 12 millimeters, mark it. Then we'll introduce our fold seaming pliers, just an initial crease. This one is 43 degrees on our angle gauge. You can see here I've preset it. Bottom of it sits flush. We need to make sure that that point here and here are in alignment. We'll do fold 5. Again, it's just an introduction of a curve, because later, when we're actually fitting it to the car, we'll be fine-tuning it even further. I've initiated the bend, you can see there, just the angle. Now we'll go to step 6. Using the tapered T-dolly, the center of the T-dolly has to align with our mark. Make sure the tail is here at the fold point, and then we're going to apply a little bit of even pressure on both sides just to initiate a crease line. Now we're in the correct orientation position over our T-dolly. We need to apply even force with the left and right hand, just so that you can already begin to see that it's beginning to form or pre-form this arc in the back here. So the idea is, because later on when we go to fit it, we're removing some of the manipulation required at a later stage. And the end result is we now have an arc here. You can see that this face has now become quite vertical. That's as far as I can go at the moment with our handmade inner wheel arch. I need a pair to trial fit to the car, so I'll be making the other one using machinery and equipment. It'll be much quicker and we'll get a far better outcome.